All of you welcome in your next period. To see the next article, the principle of least action. It is associated with the Hamiltonian formulation which involves delta variation. Hamiltonian formulation which involves the delta variation. This variation is less constant. The varied path over which an integral is evaluated may end at different times than the correct path, and there may be variation in coordinate at the endpoints. We obtain delta variation of the action integral. Action integral means integration of L dt from time t1 to t2. That is del, that is variation of integration L dt equivalent to integration from t1 plus delta t1 to t2 plus delta t2 L of alpha dt minus integration L of 0 dt integration from t1 to t2, where L alpha denotes the integral is evaluated along varied path and L0 correspondingly indicates to the actual path of motion. Now these are the notations L0 and L alpha. Equation 1 consists of two paths. Variation of the integration L dt equal to L of t2 del t2 minus L of t1 del t1 plus integration of del L dt. The variation in the second integral, that is del L, calculated through a parameterization of varied path. Same as that in the Hamilton's principle, except the variation in QR does not vanish at the end points. Draw the figure. The coordinate axis qi qj. The two parts are given. There is t1 to t2. Here t1 point, t2, t1, t2. Now this is del dq and this delta q. Now this alpha and alpha equal to 0 here. Therefore, the variation of del L is integration del L dt equal to integration of del L by del q minus dt of del L by del qy dot into delta qy into dt plus del L by del qr dot del qy integration from 1 to limits from 1 to 2. Now by Lagrange equation, the value of this bracket is 0 according to Lagrange's equation. Therefore, we have only second term, and del L by del qy dot equal to pi. Therefore, pi into del qy limits from 1 to 2. Therefore, variation of L dt equal to L of t2 delta t2 minus L of t1 delta t1 plus pi delta qy limits from 1 to 2. Now this is nothing but L of dt limits from 1 to 2. If we put the limit, then we get this equation L of t2 delta t2 L of t1 delta t1 plus second term pi del qy limits from 1 to 2. Therefore, combining we write L delta t plus pi. Now value of this del qy is given by delta qy minus qy dot delta t. Therefore, pi del qy minus, we solve this bracket and adjusting this, rearranging, we have this, and this bracket is nothing but H Hamiltonian. Therefore, integration L dt equal to pi delta qy minus H delta t limits from 1 to 2. Then we continue the remaining. To get the to obtain the principle of least action, we consider the three qualifications as to obtain the least action potential, we consider the three qualifications as: first, only systems are considered for which only systems are considered for which L and therefore H are not explicit functions. Or not explicit functions of time. And in consequence it is conserved. Second, the variation is such that H is conserved. Second, the variation is such that H is conserved on the H is conserved. Conserved means remains constant on the varied path as well as on the actual path. And third, varied paths are further limited by requiring that delta Qi vanish at the endpoints. Delta Qi vanish at the endpoints. Therefore, equation 5 takes the form equation 5 becomes variation of the integration action integration from T1 to T2 equal to 0 minus H delta D, limits from 1 to 2. Therefore, we can write minus h into, put the lower limit, upper limit, delta T2 minus delta T1. Equation 6. The action integral under the same conditions implies integration L dt from T1 to T2 equal to integration from T1 to T2 Pi Qr dot minus H into T2 minus T1 because of the previous equation. Then the delta variation of this equation 7 is the delta variation of 7 is del of integration L dt limits from T1 to T2 equal to del integration from T1 to T2 Pi Ui dot dt minus this term H into minus H into del T2 minus del T1 by this equation 6. And this is equation 8. Then we compare the equations 6 and 8. If we compare the two equations, then we obtain then we get the principle, which is called as least action principle. Comparing 6 and 8. This is comparing by law, del of integration from T1 to T2 Pi Qi dot dt equal to 0. That is variation of the action integration, which is nothing but the principle of least action. Which is the principle of least action. So this is the derivation of the principle of least action.